Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogwa Jr., a mathematics tutor and an instructor of mathematics at the University of Liberia. In today's lecture, I will be looking at differential equations, and particularly, I'll be looking at variable separable part 2 or type 2. So in the first step, we had the case where we could easily separate the variables on both sides of the equations so easily. In the second type, it's a kind of form wherein we have to bring in some substitution, carry on some derivatives, and before we resubstitute it back into the problem, then the problem now becomes variable separable. So let's see how we can solve another problem. So if we have the integral of, not the integral, but dy by dx equals to cos of x plus y. Now, question 34. What if we had this problem? Dy by dx equals to cos of x plus y. Now, this is my advice to students. Whenever you see a problem, now this is calculus. When you see a calculus problem, don't look at the problem and say, this is easy. When you just see a problem and say, this is easy, I can solve it, I'm not practicing it, you are not studying math. You are just reading the mathematics. And what will happen to you? You're going to practice doing your exams. Because when you start to solve, no, I've made a mistake. And you will just be tearing papers, doing your exams. So the best thing you can do for yourself, practice, practice, and practice. Because every given problem, there is something within our problem that the author wants you to grab. There is some kind of technique within our problem that the author wants you to grab. So take note of that and practice as many problems as you can. Now, we have dy by dx equals to cos of x plus y. So we bring in the substitution again, like previous problem. We say let u equals to x plus y. Then we differentiate u with respect to x. So we will have the u all over dx equals, the derivative of x is 1. The derivative of y is dy by dx. So this is the first step. The next step is for us to solve for dy by dx. So we have the u now over dx minus 1 equals dy by dx. So that's where we see our dy by dx will look right. Du by dx minus 1. And then on this side now, cos of x plus y is just u. We can multiply our side by dx. Du minus dx equals to cos of u dx. Then we can send this dx across. So we will have the u equals dx plus cos of u dx. You can factor out dx. So what happens? You have just 1 plus cos of u dx. We have factored out dx. Now, this is dx. So since this is x, we cannot have u expressions here. So we must divide this out on, we must get rid of this by dividing it on both sides. 1 plus cos of u. So now this will cancel. You have the u all over 1 plus cos of u, all equals to dx. Now the variables have been separated, we can integrate. Now, 1 plus cos of u, remember in previous problems we told you, use the identities. 1 equals to cos square u over 2 plus sin square u over 2. Also, cos of u is just equals to cos square u over 2 minus sin square u over 2. So this came from the Pythagorean identity, and this came from the double angle identity for cosine. That is, cos of 2x is equal to cos square x minus sine square x. This was exactly where we derived this one from. So we now replace. We have the integral of du all over 1, which is cos square u over 2 plus sine square u over 2 plus cos square u over 2 minus sine square u over 2, all equals to x, because the integral of the x is just x. So what happens? The second term carry out the last term. So we have the u all over this plus this gave us 2 cos square u over 2 equals to x. So 1 all over, now we bring this 2 outside, it's like 1 over 2 comes outside like this. But 1 all over cos, we know that is secant, so this is secant square u over 2 du equals to x. So we have 1 over 2. The integral of secant square u over 2 is, okay, so it's just tangent square, tangent of u over 2 times. Now, if you were asked to integrate, for example, the integral of sine of 2x dx. Now, if you don't know the direct formula, you can say let u equals to 2x such that du equals to 2 dx. So now, if you replace it now, you divide this out by 2 first and replace the u equals to dx. So this will be sine of u du over 2. You factor out these 2, you just have sine, the integral of sine of u is just equals to minus cos of u, whereas u is now 2x. But there is 1 over 2. So that's why the general for sine is just the integral of sine of ax, some ax. So it will be negative 1 over a cos of ax. The same thing with this one. The same thing with this. Let's see, that's okay. The same thing with this. So remember, our a right here is 1 over 2. This is our a, 1 over 2. So this must be, let's do it like this, 1 over a, which is now 1 over 2. Then we have secant inverse, or not secant now, but tangent of u over 2 equals to x plus some arbitrary constancy. If this 2 comes up, this will cancel this. So we will have tangent of u. What is u? What was u? From the beginning, u was x plus y, all over 2 equals x plus c. So this is the general solution of the differential equation using reducible to variable separable. So thanks ever so much for watching. Please don't forget to subscribe, like the videos, share it,